Okay, so once again, I messed up and I did 9 out of order for number 8. Number 8's on the next slide. I'll just tell you now that for number 10, I don't have the data set that they're referring to because that's out of your book in Appendix B, and I don't have a copy of your textbook, unfortunately. I'm just reading it to see if there's anything I can tell you about that one. So I'll do 8 and 9 and get you started on those. And unfortunately, I don't have the data for number 10, but you probably can take from the questions that we have done a good idea of what you need to do for number 10. Okay. So for number 9, what you're going to have to do here is you're going to have to calculate your mean first of all. And so you're going to add up all of these numbers here and divide by the total number of numbers to get your mean. So we have 2, 4, 6, 8, 10, 12, 14, and I think 15. And so you add them up, divide by 15, that's going to give you your mean. The other thing that you need is your standard deviation. And so you're going to, again, have to work out your standard deviation. So I don't know what your mean is. Let's say it's 35. Okay, I don't think that's correct. I just guessed at that. But your standard deviation, you're going to get that by going through and first of all finding all the deviations by subtracting the number from the mean. So 32 minus 35, that would give you a deviation of 3. 32 minus 35 will give you another deviation of 3, and so on. And you add all those up and you square them and you divide by n, which I think is 15, and then you square root your answer to get your standard deviation. So you can find that formula in your book, but you probably already know how to do that under the measures of central tendency section. You probably did that much earlier on. Once you've got that information, then finding the 98% confidence interval, the z-score that you want for the 98% confidence interval is 2.33. So your error calculation here is going to be 2.33 times the square root of your standard deviation over n. And that means that when you do your confidence interval, it's going to be your mean minus your error, and your mean plus your error on the other side, and that's the range that the mean can be in order to be 98% confident. So that one's pretty easy. It's just a lot of calculations that you need to go back and do to get the numbers for the SD and for mu for your mean. Okay? So looking forward to number 8. There's number 8. And I think we've got the same thing again. We've got a sample of 40, and so n is going to equal 40. And they're giving you a mean of 23.95, a standard deviation of 2.55. For a confidence interval of 99%, your z-score is, hold on, I got them all written down here, 2.575. Okay, and so when you're doing your confidence interval for 99% here, you're going to, again, just use the same formula, mu minus the error and mu plus the error. And so you find your error using the square root of the standard deviation over n times z alpha. Okay? And so when you've got that figured out, it's just the same thing. Put it back into the formula, and you've got your confidence interval. And then it says, how does the confidence interval not contradict the fact that most of the original values do not fall between the confidence interval limits? I think that will have something to do with the fact that the standard deviation is 2.55, and that you also can't measure 0.5 of a chocolate chip. and so you can only measure chocolate chips in whole numbers, and I think that those two considerations have to go into your final answer for that part.